All right, thanks everyone for coming along to Greg's seminar, which is on end-user creativity and the appropriation of IT systems. So, big hand for Greg.
Thank you. Good afternoon. Thank you for coming. So I'm studying end-user creativity. Why is this important and why does it matter? Well, I can give a couple of reasons. Bicycles were designed as on-road transportation. Although people who ride bicycles have been modifying them in various ways for use in different contexts for a while. In the 1970s, users began modifying a certain brand of bicycle with larger tires and tweaked suspensions specifically for off-road use. Today, the market for mountain bikes in the US is estimated at over $6 billion per annum. So sometimes end-user creativity can be useful. In 1974, the McDonnell Douglas DC-10 airliner was one of the most popular planes in passenger space. The cargo hatch of the DC-10 had a special locking system that was designed to reinforce it against the pressure differentials between the inside and the external and the outside of the fuselage at high altitude. This locking system sometimes made it difficult for ground crews to close the hatches. However, the ground crew at a certain airport discovered that making a minor modification to the latching system completely solved that problem and made it almost effortless to close the door. However, it didn't work out well. So sometimes you want to restrain or suppress user creativity. But what are the design practices that you should use in each case? If you're a manager, how should you stimulate or suppress the creativity with which your users apply your IT systems? Surprisingly little empirical work has been done on this. And so my thesis is aimed at addressing this gap in the literature. I've taken a case study approach, and I've worked in a number of different systems, in a number of different organizations, in different lines of business, using different types of systems for different types of tasks. And so I have quite a varied data set. However, that brings with it some problems. Data is quite messy. How do you figure out what is comparable to what? How do you measure? What are you actually studying? Those are questions that you need to address. And so I've chosen what's being called in the literature a mechanism-based explanatory approach that's designed to figure out the hows and whys of causal relationships. This causes that, how, what actually happens. And I'm using an explanatory paradigm that uses the mechanism-based approach called critical realism. By paradigm, I mean basically a set of assumptions. Every time we do research, we make assumptions. We make assumptions about how things can be measured and what correlates with what. And critical realism is a set of assumptions that have proved useful in understanding certain kinds of data. And so I want to talk about some of the underlying assumptions in critical realism because it will make it easier to understand the work I've done. So CR maintains that there's a stratified ontology, that the world is made up of three domains. There's a domain of things that we see and experience, which they call the empirical domain. However, we can tell that there are things that happen which we do not actually see or directly observe. And the domain of things that happen is the domain of the actual. However, we do know that sometimes it seems like things cause things to happen in the actual world. I flip the switch and the light comes on. But that doesn't always happen. Sometimes I flip the switch and the light doesn't go on. So that means that there is something working in the background which has some kind of link between the switch and the light. And if I understand that, then I can better understand why sometimes the switch works, why it doesn't, and under what circumstances it doesn't. And we call the domain in which those causal mechanisms exist the empirical domain. Now, we propose that the empirical domain is composed of structures, which is basically things and what they're made of. Powers, which are things that structures can do, capacities for action. And tendencies. Some powers tend to work in a certain direction, even though they don't always. So the flipping a switch has a tendency to make the light come on, even though it doesn't always work. Now, critical realism assumes that the world is an open system. In other words, structures, powers, and tendencies, which together we call mechanisms, exist in a world where there are a lot of them and they all interfere with each other. And so that means, for example, that we cannot perform an experiment and say, okay, this led to this in my experiment, therefore in all cases this is going to lead to this. Because there are other mechanisms that may be involved, that may interfere with the relationship between this and this. And so we strive to explain and not predict what we see happen, and we explain through mechanisms which are sometimes but not always unobservable. There's also principles of multifinality and equifinality, which basically just mean that sometimes different mechanisms can have the same outcome, or the same outcome can result from different mechanisms, or the same mechanism can lead to different kinds of outcomes, depending on what else is going on in the system at the time. And also we recognize the principle of emergence, which basically means that at any level, mechanisms can be decomposed into other mechanisms. And understanding the mechanisms that make up a system don't necessarily allow you to understand the system that they make up. Just because I know the different people who work in the HIT lab doesn't mean I can automatically say something definitive about the HIT lab without actually looking at its behavior. Now, the assumptions underlying, and I'm very much glossing over some rather technical literature because I don't have time to do real justice to critical realism. Some methods emerge from the underlying assumptions of critical realism. We strive to identify the underlying structures and mechanisms that are involved in any event that we look at. We make observations in the empirical domain in order to understand the mechanisms that are at work in the real domain. Mechanisms are like theories. They can never truly be proved in a real sense. So we treat them like hypotheses. We look at the world, at an event that happened in the world, and we ask a question: what must the world be like in order for this event to have happened? And we hypothesize a mechanism through a process called retroduction. And then we look at the data and we try to test that mechanism to see if it provides an explanation for what happened that stands up. Now, I'd like to introduce one of the theoretical lenses that I'm using, and that's dual process theory from cognitive psychology. Dual process theory states basically that there are two processes of reasoning that are at work within the human mind. The two processes have been described by Stanovich and West as System 1 and System 2. System 1 is fast. It works without effort. It's automatic. It's fundamentally associative in nature. It's actually composed of a number of parallel processes which are able to work without interfering with each other. And it's non-conscious. You can't feel it or observe it working. System 2 is slow. It requires effort. It's rule-based. It's serial. System 2 processes generally cannot work in parallel without interfering with each other. And it's conscious. When you say I, you're talking about your system 2. Because your system 2 is all you're aware of. System 2 doesn't know about system 1. You can't feel system 1 working. Both system 1 and system 2, I should say, are emergent from lower-level cognitive processes. They don't actually exist. They are a classification scheme for different types of mechanisms within the brain. And different researchers have proposed different models and different labels for them. But this is a way of understanding how the mind works, and it's one that I'm going to be using in my study. Now, let's have a look. Stop. Don't calculate the answer yet. You were able to not calculate the answer. You have volitional control. This is your system 2. Meet system 2. If you were to go through trying to find the answer for this, you would need to, it would require conscious effort. You would not be able to pay attention to other problems while you were doing it. And as I said, you would be able to describe the process by which you come to the answer. The process of applying the rules that you know for multiplication to this problem would be something that you're able to describe to me if you want. Okay. Meet system 2. You did not have to go through any kind of rule-based process. You automatically knew what the answer to this question was. You would not be able to describe to me how you knew. The feeling that you had when you looked at the dots was one of recognition rather than one of making any kind of conscious effort. If I told you, don't just assume that you know the answer. You need to go through and consciously process it. You would have to effortfully suppress the knowledge of the answer and then apply conscious effort to actually counting the dots. Go ahead, please.
Is counting sort of the best example for this system 1?
I know, because at some stage it breaks down.
Yes.
3, well, it's
I probably still have to do making. Well,
I'm not sure.
because well, it sort of reminds me of the pre-attentive attention. You know, when you some process
or some things you can process on a pre-attentive level that's sort of below 200 milliseconds, whatever.
that's sort of,
If you have, for example, a whole bunch of colorful processes, colorful stimuli, for example, in blue, and
there's just one red
dot in there. It doesn't matter how many dots there are, you always can spot the one different dot just pre-attentively without any cognitive effort.
Yes.
And it's sort of not
depending on the number of stimuli, I guess. But if you sort of were to count, I think it does depend on the number of stimuli.
Recognizing that one dot is red in a sea of blue dots requires processes that have been classified as system 1. It's important to remember when we're thinking about it that system 1 and system 2 are a classification scheme. In fact, Stanovich and West, who invented the terms, actually don't use them anymore. They prefer to talk about type 1 and type 2 processes. So there are a number of different phenomena that have actually been brought in to the explanation of the mind that is represented by dual process theory. but it has proven in a wide number of domains to be a good way of explaining how the mind works. And the reason why it's important to understand System 1, why it's useful to understand System 1 and System 2, is because we live in a world where there are situations that Sloman described as, or a researcher named Sloman described as criterion S problems, where the two systems lead to different answers to this, or different responses to the same stimulus. For example, which line is longer? Now, some of you will recognize this as the famous Mueller-Lyer illusion, and I can tell you that the two lines are exactly the same length. But if you're not familiar with the illusion, maybe you doubt me, so can I have a volunteer?
Oh.
Yes. Well, thank you very much for volunteering, Ken.
Thank you for forcing me to do it.
Yes. Okay. So let's measure the bottom line. Okay. So that's about exactly 18 inches long. Correct?
Yes.
Okay. Now don't move your hand. Just slide it up. Just slide it up to the top line. How long is it?
Exactly the
It's
same.
exactly the same length. Thank you very much. All right. Now that I've told you and I've demonstrated to you that the two lines are exactly the same length, if you look at them again, the bottom line still seems shorter than the top line, doesn't it? Right. The cues that are provided by the fins on the ends of the line activate mechanisms that are in System 1. You cannot turn it off. You cannot stop System 1 from processing a stimulus that it apprehends. And so if you were going to perform some other mental operation that involved knowing that the two lines are the same length, you'd have to actively suppress what you sense because of System 1 in order to act on what you know from System 2. Now, there's a third level of cognition, one that was proposed by Hutchins, and is known as distributed cognition. This basically, without needing to go into any kind of technicalities, this basically proposes that cognition is a computational activity, and not all aspects of the computations involved in cognition are confined to an individual. And so cognition can span multiple individuals as well as objects, representations, and tools used to extend cognitive processes. And so when I extend my memory by consulting my speaker notes, I'm engaging in cognition that is not only in my head, but expands to involve an object, a representation, a tool. When I collaborate with someone else on a project and we share our knowledge and our skills, we're engaging in a process of distributed cognition. And this model of the world and of how we think is well established. It's been widely used. In a lot of engineering contexts, it's been used to look at problems like navigation and aircraft cockpits and the functioning of teams. And it's another way of looking at cognition. And so the key points to take away from this is that there are essentially two systems of cognition within the individual. System 1 is automatic and it's always on. System 2 is lazy. That is, it's programmed to minimize effort. System 2 is effortful, it burns a lot of energy, and it's serial. It can't focus on more than one thing at a time. And so it's programmed to spend as little effort as possible on anything so that it can focus on the important things. Now, because of those two tendencies, system 1 to always be on and system 2 to work as little as possible. The overall behavior of the system is determined in a lot of ways by system 1. Because system 1 is constantly saying, do this, do this, do this, do this, and system 2 doesn't want to go through the effort of figuring out what to do, very often the whole system just goes along with system 1. But system 2 is not aware of this. And that has a number of implications. Also, cognition is not limited to the operations of system 1 and system 2. Processes and objects that are outside of the individual are also part of cognition. And so in critical realist analysis, one of the important tasks at the beginning of the analysis is to identify the structures which are involved. However, for my case data, it's been suggested by some experts, by Wynne and Williams, that because of this, critical realist analysis is ideally suited to single case contexts. I respectfully disagree. From the literature, critical realism aims to make general statements about the world in the way of all science, and the findings of a critical realist study should be applicable across different contexts. The solution is to use a theoretical framework that can pull things together across contexts. However, the problem for my study is that no suitable framework for modeling the ideation and enactment processes that are involved in creative activity by users exists. And so I had to build one. I started with this foundation, adaptive structuration theory, which is a very influential and powerful theory in information systems. It was developed by DeSantis and Poole, and in order to address some ontological problems with the theory, it was reformulated by Marcus and Silva in 2008. It uses three key concepts: technical objects, which are basically IT artifacts, and outputs of IT artifacts like printouts, images on a display, etc., etc. Functional affordances, which are relationships between the properties of objects and users that enable the users to make use of objects in some way. Comes from the concept of affordances that was developed by Gibson a few years ago. And symbolic expressions, which are basically messages to users, both from designers and from marketing, etc., about how technical objects should be conceptualized and used. And then I went into the source literatures that they applied in developing their concepts, and I dug in and extended the concepts a bit. I've extended the functional affordances concepts by bringing in some conceptualizations by Gavin. I went into the ecological psychology literature and brought out the concept of user effectivities. I developed the concept of symbolic representations. Symbolic representations are the mental model of an IT system that is held by the user. They are not, or SR is not the same as user, perceptions of the system. Because perceptions, if you look at the literature, are typically measured by things like self-reports. However, a large portion of our behavior is determined not by things that we're able to see or feel or think we know, but by things that are part of System 1. So on a conscious level, I could think this is a great laptop. On an unconscious level in System 1, I might have a schema that associates the laptop with another laptop that looked just like it and failed. And so my behavior toward the laptop may not be directed entirely by what I think I feel about laptop, but by the unconscious associations that the laptop has for me. And so I've developed a framework from that, and we can represent the framework using Gibson's metaphor of a visual field. Because Gibson actually, when he invented the concept of affordances, was working on visual perception. And so we start with a large field which represents all the potential actions that anyone could do with any IT system. We call it, okay, all right, we call it the field of all action potentials. However, no single system can use every action, can do everything that you can do with a system, and so the properties of the system determine the action potential field of the system. This is everything that you could possibly do with this system. However, no single user will have all the skills necessary to do everything that you could do with the system. If this system could be used to design art, and I don't have the skills to design art, then that action potential exists for the system. But if I use the system, I'm not able to do it with it. And so the user effectivities, things that the user is able to do, determines what I call an affordance field. Everything the user can do. However, the user also has a symbolic representation of the system, which represents what the user perceives herself to be able to do with the system. Now, the symbolic representation that the user has of the system determines what they perceive they can do. It determines the perceived affordance field of the system. The perceived affordance field is not necessarily the same as the affordance field. The user might feel they're able to do something which they're not in fact able to do, which leads to false affordances. The user might not perceive themselves as able to do something that they can actually do, which leads to hidden affordances. The symbolic representation is determined by symbolic expressions which influence what the user feels or what influences the user's mental model. Now, what I call the technology in practice, borrow that from Orlikovsky, which is the user and the system together, the socio-technical object that they form, has this range of things that they can do. Now, some of those things fall within what I call the normative affordance field, which is what people usually do with this system. So if I wanted to make a budget, and I use Microsoft Excel to set up a spreadsheet and make a budget, that would probably be within the normative affordance field of Excel. If I wanted to design clothing, and I found a way to use Excel to design clothing, then that would probably fall outside the normative affordance field. And so this appropriation move, this is a term from adaptive structuration theory for actually using the system to do something, where you're able to make an appropriation move depends on all of those factors that go into where your perceived and actual affordance fields lie. And if you're making one that's creative, it's probably going to be outside of the normative affordance field. And you can ask, well, why? Why was this person able to make this appropriation move when it's not normally done? There are also a number of tendencies in affordance field theory. I model that affordance fields can be stretched or widened in orthogonal axes, with widening representing finding new ways to apply features and stretching, modeling, developing new features. Now, I won't spend a lot of time on my methodology. Basically, this is how I'm analyzing the data. And I'm using a number of conflicting isn't the right word, of different techniques, which I hope will triangulate and corroborate the mechanisms that I come up with. Now, if I explain it, it sounds linear, but in practice it's iterative. Do it in circles. And so I can demonstrate what the results will look like by looking at a couple of mechanisms that will possibly be in the final version of the thesis. So there is what I call the Abstraction-Association Mechanism, which works by abstracting away the specific details of a previous problem-solving solution to form a model. And then it associatively matches the characteristics of a current problem to the previous model, and then applies elements from the previous model to the original problem in order to come up with a solution to that problem. And so this is what that looks like, the Abstraction-Association Mechanism. Let's look at another one, what I call the retrospective reframing mechanism. Now, I found in a number of cases that the people who came up with ideas seem to have been influenced by things that they had been exposed to in the past or by previous ideas that they solved. But in many cases, they didn't seem to be aware of that. Looking at the data, I could see it, but they didn't. Why did that happen? So I have hypothesized the RRM. Its basic function is to write narrative accounts of creative events to long-term storage. The process by which it does that is it receives incomplete narrative information about the event. It also receives an abstract script for how the process should work. And then it replaces the missing information in the narrative with the information from that script in order to come up with an associatively coherent narrative for what happened and write that to long-term storage. So this is what that looks like. Receives the event data, and it works with a number of what I call prototypes, which are pre-existing scripts about how the creative process works. At the level of system 1, the prototypes I call schemas. At system 2 level, I call them stereotypes. And at the distributive cognitive level, I borrow from Jung and call them archetypes. And at each level, they write to a different kind of storage. At the S1 level, they reinforce the schema. So they write back to the schema. When an understanding of what happened is created by the incomplete event data plus the prototype. At the S2 level, it writes to beliefs, and at the distributed cognitive level, it writes to representations, books, written reports, stories that you tell other people. Now, there are a couple of things I'd like to point out about this. First of all, I know some of you will have noticed this already. The RRM seems to be a type of the AAM. It seems to be a more specific formulation of the same form of mechanism that the AAM was. Pre-existing problem, current problem, solution. Here are the pre-existing problem, the prototypes and the event data. They get mixed up in the middle, and then the solution is the outputs that they write to. Also notice that each of these things both write out and they reinforce each other. So existing archetypes lead to stereotypes, which help to form schemas. And so what are the implications of that? I think there is possibly going to be a taxonomy of mechanisms with more general types, which Hedstrom calls mechanism schemes, which show general forms of information processing, and more specific ones which are specified at the different levels of cognition which actually act on the world. The implications of the RRM itself are interesting. One of the effects of it is to terminate the search for a solution to how creativity happens by creating a real-seeming explanation. It makes creativity hard to study because it perpetuates myths about creativity. And I don't think it works just in terms of how users come up with new ways to use systems. It works in a lot of ways. For example, critical realism itself. If you look at most papers and books on critical realism, you'll see that it was invented by Roy Bhaskar. However, as some other researchers have pointed out, Bhaskar was one of a number of philosophers in a small area, in a small period of time, who came up with very similar worldviews. So obviously they influenced each other, and it's more complicated than that. But why do most people just say, well, it was invented by Bhaskar? Well, because it corresponds to a very powerful and enduring stereotype, which is the stereotype of the lone inventor. Almost every serious study that has looked at this has shown that that is not a correct understanding of how significant creative things happen. Creative discoveries are usually made by collaborating teams. However, the stereotype of the lone inventor exists. Why? Because the RRM simplifies and reinforces the stereotype, simplifies the actual story, and then reinforces the stereotype as it does so. Now, this makes creativity hard to study, but it's not a problem per se. It's just how the system works. In fact, Hutchins, when he was talking about distributed cognition, mentioned this. The simplification process, and said that it's a necessary part of the system because it reduces the bandwidth that's necessary. And that's true mentally as well. If we understood all the details of everything that we talk about, we wouldn't be able to function. And so, as researchers, I think we have to understand what's happening, not because it's a problem or something to be fixed, but because it can influence what we study. We can find ourselves unintentionally studying the simulacrum that's created rather than what actually happens. And so, in summary, what I'm working on is to derive information processing mechanisms that explain my case data. The mechanisms will probably be specified at the 3 levels of cognition, System 1, System 2, and the distributed cognitive level. When I understand the mechanisms at work, when I'm able to explain all the case data in terms of this mechanism was triggered by that, and then that mechanism was triggered by that, and so on, then I can make some empirically based general statements about end-user creativity. And already I'm seeing in my data some things that do not match existing thought and existing theory about how creativity works. And I can explain some of those things in terms of the activational characteristics of some of the mechanisms that I've already been able to specify. This is for a thesis, and so I've given some thought to what contributions work will make overall. But basically, for right now, that is about it. And so at this point, I'd be happy to take any questions, comments, suggestions. Name it.
Should we give Gregory a big hand?
Could you give a couple of examples of the cases that you're using?
I can. I have to do so very carefully because, of course, I need to maintain, anonymity. I'll have to think about it really hard before I can talk about them comfortably, because I have to think about what I can and can't say without making it impossible for an informed observer not to figure out who I'm talking about. But basically, I'm looking at a large software development company, a company that does fashion design. I've looked at a couple of cases at a large educational institution. I've looked at one fascinating case where a number of different organizations, both a disaster relief organization and a number of manufacturers of IT systems, have collaborated to develop a system for a certain kind of disaster response. I've looked at a company that designs medical devices, designs and produces medical devices, and I've looked at a company that offers medical services to clinics in remote parts of the country, and so on. And in terms of what they actually do and what systems they're using, as I say, I've heard horror stories about, we showed the student our secret product, and then the student put his PowerPoint slides on the web, and there was our secret product. So I'm being careful.
Sure. No,
But
so, but useful context.
So how
Yeah.
does the data collection that look like? You just go there and observe, or
Basically, I go into the organization, and I ask a version of this question: what's the most important IT system? What's your most important business process, and what IT systems do you use to carry out that process? And then I talk to people who use the system, and I try to identify a case of system was designed to do this, but we made it do that. And then I interview the people who were involved in that process using a structured protocol. And I also collect any data I can get, any kind of documentation, anything they put on the web, anything that they are willing to give me, looking at the system, observing people using it, and so on. I collect everything. And then when it's all collected, I have the fun job of analyzing it, which can get interesting, but I think it's necessary at this point. What I'm doing right now is really exploratory. A lot of work has not been done on this, quite surprisingly. And so I'm trying to understand the process at a very basic level.
so? But I think sort of at some stage you talk about generalizability of your results.
Don't you have to be a little bit careful there?
Because you're dealing with case studies.
Mm-hmm.
And while you try to find
Common mechanisms, common sort of procedures, common things there. Don't you have to be a little bit careful then? Just okay, we found something really that can be generalized here in terms of data processes.
Well,
I'm
Robert.
always a little bit sort of skeptical. Well, case studies are good for what they are,
Mm-hmm.
but is it sort of
just the step from case studies to generalizable results is
Well,
sort of a very interesting one.
It depends on what kind of generalization you're trying to do. Robert Yin has written quite a bit about this. One of the mistakes, frankly, that case researchers sometimes make is trying to statistically generalize their results to populations as though they were working from a randomly selected sample. That is not what case studies are. When you generalize from case studies, you don't try to generalize and say, all right, well, this happened in this company, so it happens in all companies. Instead, you try to generalize to theory. In other words, you say, okay, this is what happened here. This is why it happened, so this is how this works. And then the this is how this works explanation is one that, in theory, you should be able to find evidence for by doing statistical testing. However, with case studies, you don't attempt to generalize to populations, but rather to theory. And in my case, I am working from case data, but I'm also pulling in and treating as data existing theories, which are based on hundreds of experiments and empirical projects over many, many years.
Would that still classify as generalization, or just
try to corroborate a theory?
It would be corroboration. But as I say, this is something that has been written about extensively in IS because it's a big point of debate between, say, case researchers and researchers who do things like experimental and survey-based work. And the basis on which I am moving from my data to say this is the way the world is quite solid in terms of theory. Now, another thing should be said when I say that, which is that in critical realism and in research in general, we're always very conscious of the limitations of any one study. And so I don't see my study as answering all the questions in terms of how users creatively appropriate IT systems. But I see my job here as being more to lay a solid foundation for a program of research that's aimed at understanding this. I think it's an important problem, very understudied, and that the approach I'm taking lays a good foundation for doing further empirical work. Yes?
There is a differences between kind of survey work and experimental, as you mentioned, but how you know that, or can you estimate the kind of completeness or the level of completeness of your survey or the data you collected? Something which is about this, because collecting the data seems to be hard and you are not aware of how much you are missing.
Yes, that is true. In my own case, what I'm using is a principle that we call theoretical saturation. In other words, you keep on collecting data until each new case doesn't add anything to what you know. From my study, I'm defining theoretical saturation as I see each mechanism at work in more than one case. So when I study a new case, what happened can be explained in terms of the mechanisms that I've already found. I don't need to add another mechanism. And so the only way that you can actually be certain of that is to continue doing your analysis as you're collecting data. And so that's what I'm actually doing now. I'm analyzing the data I have and making sure that, or trying to make sure that I understand how much I know, how much more I need to get.
How you determine when to stop? Because you can collect data, maybe it never adds new data, but you have to use some criteria.
Yeah. Well, as I say, the criteria that I'm using is each mechanism is confirmed, and confirmed not in the sense of yes, I absolutely am certain of this mechanism, but confirmed in a technical sense, which means this mechanism worked in this case here, and it also worked in this case here. So I've seen it work in more than one case. So that is basically the criteria for theoretical saturation that I've applied in my study.
Right, well, if there's no further questions, we'll give Greg another big hand.